joke. You can't laugh when I don't tell you a joke, because then you will not laugh when I tell you a joke. That was a joke. See, nobody laughed. Okay, F5. So, where were we last night? If you guys remember, good. If you guys remember, we were talking about no cell phones. All cell phones, please stop using cell phones. We were talking about, he's not listening to me, stop using cell phones. We were talking about how to find out the capital cost of a plant, right? And we said to figure that out, we have two different ways. One is we can do an order of magnitude estimate, for which all we need is a block flow diagram, and we simply take capacity into account by using the cost exponent. What is the cost exponent for entire chemical engineering plants? 0.6, very good. So we just scale up the capacity to about 0.6, and that takes care of capacity. How do we take care of the time of when the plant was constructed? How do we take care of that? Using SEPC, very good. So using those two, we can find out the cost. But of course, that's a very, very rough estimate. That's always the first estimate we get. If that estimate suggests the cost or something we can handle, we move to the next estimate, which is called a study estimate. To do that, we need what kind of diagram? A process flow diagram, because we need more details in the plant design. Once you have a process flow diagram, we can go to each and every equipment, and we can figure out the cost of that equipment. How do we figure out the cost of that equipment? What parameters do we need to figure out the cost of an equipment at, let's say, base conditions? Very good, K1, K2, K3. So if you know the capacity, you look at the table, figure out K1, K2, K3, and you figure out the cost of the equipment under base conditions. It works for most equipments, but some of the equipment that doesn't work, the table kind of tells you how to get to it. Okay, once you get the figure out, but is that enough? Is that the entire cost of the plant? Just add up all the equipment? No. The other cost, and to take this into account, you have to calculate what is called the bare module cost. And how do you calculate the bare module cost? You multiply the cost of the equipment under base conditions with what? It is called FPM, the bare module correction factor, which is B1 plus B2, FM, FP, right? B1 and B2 are constants that you can figure out from the tables. FM is the material factor, FP is the pressure factor. FM, the material factor, you have to look at the type of the equipment, type of the material, get an ID number. From that ID number, you look at a chart, and you look at the FM. FP, either you look from a graph, or you have some equations in terms of parameters C1, C2, C3. Okay, so you look for C1, C2, C3 for the equipment, and you figure out FP, and you are golden, right? So you calculate the bare module cost for each equipment, you add it all up, you get the bare module cost of the entire plant. Now sometimes you want to convert this bare module to a total module, so you add contingency and fee, and if you want to add the grassroots cost, you add another 50% to the bare module cost under base conditions. All right? Everybody's good? Really not, really nothing very difficult except that you just have to look at the tables. For different equipment, you have to look at different tables, and it's all in the appendix. I really want to encourage you to borrow a book. If you don't have the book, at least borrow a book from somebody. Look at the appendices. Look at where the tables are, how the tables are. As I said, I'm going to give you a take-home quiz, which will require you to use that book. And it's take-home, so hopefully if you don't have a book, you'll be able to borrow it from a friend. I will let you borrow my book, but of course it's only one book. There are lots of, yeah.
Can I borrow your book?
Well, not right now. It's in my office. So you have to come to my office. And not today. Only after I give you the quiz. But anyway, if you do copy a part of the book, make sure you do not break any copyright laws. Okay, the copyright laws are typically given at the beginning of the book. Make sure you don't violate those. But I think you're allowed to copy certain tables without violating those. So I think you'll be okay as long as you don't copy entire chapters. Okay, good. Any questions? Also, the book has a software called CapCost. At least for those of you who have the book, I encourage you to look at that software and just see how easy it is to just input information. And the software will use the same equation that actually you're going to use. but it's just that it doesn't have, it knows where all the constants are, so it's easy enough for it to figure out the cost. All right, good. So let's say we know the capital cost of the plant. So as we talked in the beginning, to figure out if a plant is profitable, we need to know the capital costs, which are the costs that you incur up front. But then, of course, what else do you need to know? The operating cost, right? Which is the cost that you incur year after year to run the plant. Very good. And we already talked about what those operating costs are. They're also called cost of manufacturing. Okay? So today, we're going to talk about estimates of manufacturing costs, and this comes from chapter 8 in the book. So this is what goes into, and again, I haven't uploaded slides so far, but I'm going to upload all the slides all together for the 3 parts. And that's all. This is all I'm going to use with PowerPoint. After that, I'll just go to the board. So the 3 things that I'm using PowerPoint for are the diagrams, and the cost of manufacturing, and cost of operation. Okay, so those 3 chapters, I will put these slides up online. Okay, so this is what comes to the cost of manufacturing. There are direct manufacturing costs, and then indirect, which can be broken up into fixed manufacturing costs and general manufacturing expenses. The categories are all quite self-explanatory. The direct costs are essentially directly related to the production, cost of raw material, waste treatment, utilities, labor, maintenance and repairs, supplies, labs, patents and royalties. Fixed manufacturing costs include depreciation. We'll talk later about what depreciation is, so I don't want to get into it. Depreciation is a little bit more subtle than I think a lot of you kind of understand it right now. Taxes, overhead costs. You guys remember what is included in overhead costs?
Benefits.
Sorry?
Benefits.
Very good. Benefits, your medical benefits, retirement benefits, all that kind of stuff for the labor, and of course your workforce. And then general manufacturing expenses will include administration costs, distribution and selling costs, and R&D. Every term is quite self-explanatory. Now, in this course, what we're going to do is, we're going to estimate, we're going to calculate cost of raw material. As you can imagine, that's relatively straightforward, right? From your PFD, you know how much raw material you need. You multiply by the cost, and you have your raw material cost. Very straightforward. Waste treatment costs are becoming increasingly important, and that's why a good design is a design where you do not generate wastes. This is not true, in fact, just for a plant, but it's also true for now. I was just reading an article in some book about, in Canada, there's a school, a building, a school of construction, and the students got together with the faculty and designed this amazing home where they reduced the cost of energy and cost of waste by about 80 to 90%. So the same thing is actually happening in the chemical industry as well. You do not want to generate wastes because first of all, it's just bad for the environment, but second, it's also bad for your pocketbook. It's just going to cost money. And so waste treatment, if you're not utilizing your own waste, could be very expensive. In this course, you're not going to include waste treatment simply because that is really very subjective. Unless you know exactly what the waste is, it's very difficult to really estimate waste treatment. So we're not going to calculate it, but the key is in a good design, you should not have any waste generation or minimize the waste generation. Utilities, again, relatively easy to calculate. How will you know what utilities are required for your plant?
From the mass balance.
The PFD, right? From the mass balance, energy balances, but they're already there in your PFD, right? The PFD utility summary directly has all the utilities listed. All you have to do is go at one by one, all the streams, multiply by the cost, add them all up, and you're all done. Labor. Labor is a little bit trickier because PFD directly doesn't tell you how much labor it needs, right? So I will show you there's a correlation which you can use to figure out how much labor you need, and then of course you multiply that by the cost of the labors, and you can figure out labor costs. The rest of the costs, we are going to estimate it indirectly. So really, to estimate the cost of manufacturing, we need 5 things. One is the fixed capital cost, which is called FCI, fixed capital investment, and then raw material, waste treatment, utilities, and labor. Once you have those 5 things, the rest of them can be calculated, or at least approximated, because the rest of them depend upon those first 5 costs. You will see what I mean from the next slide. So this is the only 5 things we need. I showed you a bunch of stuff, but once you have these 5, you can figure out the rest. So as I said, FCI is fixed capital investment. That is either the total module cost or the grassroots cost, depending upon where you're starting the plant. Then of course labor, utility, waste treatment, raw material. So how do we figure out the rest? From this table. So again, the top 5 we have to calculate, but let's look at direct, supervisory, and clerical labor. So the labor costs, the supervisory and clerical labor, who are you supervising? You're supervising labor. So you could basically figure out that this cost E is going to be proportional to the cost of labor. And that's what it is. And the proportionality constant is roughly 18%. And again, it's based on historical data. So the cost for E is 18% of cost of operating labor. Maintenance and repairs are roughly 18% of, no, maintenance and repair are roughly 6% of FCI. Again, you can guess that how much you're going to maintain will depend upon the cost, the initial cost. And if it's 6% per annum, roughly you can see in about 15 years you would have spent as much money in maintenance as the actual cost, without taking into account, of course, depreciation and the cost and the interest. So roughly this makes sense, right? 6%. So the maintenance every year is only about 6% of the initial investment. Similarly, operating supplies are about 1% of the initial investment. Laboratory charges are assumed to be 15% of the cost of labor. It doesn't really make complete sense to me why the laboratory charges would be proportional to the cost of operating labor. But I suppose it depends on the type of industry you're looking at. If you're looking at pharmaceutical industry, it might be very, very different. But yeah, depending upon the type of industry, this could be very different. But in this book, we're going to assume, or for the problems we deal with, 15% of operating labor. Patents and royalties, 3% of cost of manufacturing. Everything else is straightforward, right? Because we're going to calculate that. But you might ask me, first you might ask me, why are patents and royalties 3% of cost of manufacturing? You would think that that should be completely independent of cost of manufacturing. It should depend on the type of industry you deal with. Anyway, here is an approximation. We're going to take that. But another question you might ask me is, we don't even know cost of manufacturing. Cost of manufacturing is actually a sum of all of these, right? So how can we calculate 3% of something we don't even know? So the idea is we're going to write this as an equation. We're going to add these up, and we're going to equate that to COM. We're going to take this term to the other side, and from there we can figure out COM. You will see what I mean by that. You add it all up, and you get the total direct manufacturing costs. So again, the 5 things we need to know are 1, 2, 3, 4, and 5. Okay? COM we don't know. But as I said, when we add it all up, it equals to COM. We make an equation out of that and calculate COM. I know I'm going a little bit fast, but really because if I go slow, you're going to really get bored. So I'm trying to kind of speed that up a little bit, but there's nothing subtle about this. But it's still clear. Any questions? I'll be happy to try to answer it. Any questions? No? Okay. All right, so those are the direct costs, and now fixed manufacturing costs, again, depreciation. Now let's talk a little bit about depreciation, because that might kind of wake you up. So what is depreciation? Sorry? Loss of what? Loss of value. Okay. So qualitatively you guys are actually correct. But you will see later on when we start talking about depreciation in more details. The depreciation is basically, it is a way in which the government gives us credit for the initial costs that we incur while, manufacturing the plant. Just like this. You all, none of you probably pay taxes, but let's say that, I don't know if any one of you has ever seen your parents filling up tax forms. But what do you pay your tax on? On the net, everything. For the net earnings, right? So to figure out the net earnings, of course you have your earnings, and then you subtract certain deductibles from that, right? Some of them are standard deductions, sometimes educational expenses can be subtracted. You have a bunch of subtractions, right? Now, if a company is making money, you will subtract your total, from your total income, you will of course subtract your cost of manufacturing, and you will have your total profit for that year, right? Now, but the company will say, but listen, wait a second. This is my profit for this year, but what about all the money I spent in the beginning? Who's going to take care of that? Right? So the government says, fine, you can subtract that as an expense. But you can't subtract it all right in the beginning. Because if you subtract it all right in the beginning, it's like you're getting credit for your entire expense in year one. That means your tax bill for year one will go down a lot. And the government, of course, doesn't want your tax bill in the beginning to go up a lot. The government wants to get as much money up front. Why?
Inflation.
Not inflation, but the interest, right? Money today is worth more than money tomorrow. So the government will not let you claim the entire capital cost as a deduction in year one. Does it make sense? It's like this. Let me give you an example. Let's say that you open a pizza shop, okay, and you buy a car. The car is a deductible expense, right? Because you need that car to deliver pizza. But the government will say, okay, fine, the car costs $20,000. But in year one, we are only going to let you deduct $2,000 of that as a deduction. Okay? Because if you deduct all $20,000, you may pay no tax that year. The government specifies what percentage of the cost you can deduct each year. That is called depreciation. It is somewhat similar to the loss of value, but a loss of value is a very qualitative term because the value itself is a very qualitative term, right? So tax is a very quantitative meaning. The depreciation is a very quantitative meaning. It is what percentage of your initial expense you're allowed to claim as a deduction in a given year. And this percentage is specified by who? Government. What body of the government? IRS, right? So IRS tells you, and roughly it is 10%. But you will see a little bit later, it's a little bit more complex than that. But roughly, if you know nothing else, you can assume that 10% of the initial investment you can deduct as an expense each year. Does that make sense? Okay, so that's depreciation. So it's 10% of FCI. The taxes are about, let's say, assumed to be 3.2% of FCI. Overhead costs. Overhead costs in this case have two parts. One is the overhead associated with the operating labor, but then there's another overhead associated with the fixed capital investment. And so you have those two terms. You add those, you get a total fixed manufacturing costs. And then similarly you have general manufacturing expenses for administration costs, distribution, selling, R&D. And you add all that up, this whole thing equals to COM, okay? So I obviously am not going to ask you to remember equations like this. I will never in a quiz or an exam even ask you to calculate COM. I will again give you a take-home quiz where you'll be asked to calculate the capital cost as well as cost of manufacturing, okay? So you don't have to remember equations like this. But anyway, all you have to understand is where these equations are coming from. These equations are coming from because, of course, these 1, 2, 3, 4, and 5, you know these constants are coming from because there are other costs which are proportional to these costs, and you have to add those up. All right. So this is a summary of all that. DMC's direct manufacturing costs, fixed manufacturing costs, general expenses. These equations I already told you where they roughly come from. Now let me explain to you what is COMD. COM is cost of manufacturing. The D subscript means without depreciation. Okay, so that's an important distinction. COMD, because D is a subscript D, it means cost of manufacturing without depreciation. Because if you remember cost of manufacturing, in the FMC you include depreciation, right? So if it was without D, that would be the total cost of manufacturing. COMD means without depreciation. And so that's again the direct costs, the general expenses, but you remove the depreciation from the FMC. So therefore COMD becomes simply that because you remove the depreciation. And the COM is cost of manufacturing, which is the cost of manufacturing without depreciation plus depreciation. You will see later why it is good to differentiate these two for taxation purposes. And depreciation is roughly 10% of FCI. So you put it all together and you can get an equation that cost of manufacturing can be given by this expression. So the only important thing to remember is, so the take-home message, if you have not heard anything I've said so far, is that COM is cost of manufacturing, COMD is cost of manufacturing without depreciation. Depreciation is a very